This conference will now be recorded.
We need to study structure and physical properties. So we'll start with atomic orbitals. So atomic orbitals is the region in space where an electron is likely to be found is called an orbital. There are different kinds of orbitals which have different sizes and different shapes and which are disposed about the nucleus in specific ways. The particular kind of orbital that an electron occupies depends upon the energy of the electron. It is the shapes of these orbitals and their disposition with respect to each other that we are particularly interested in. Since this determines or more precisely can conveniently be thought of as determining the arrangement in space of the atoms of the molecule and even help determine its chemical behavior, we are interested in the orbitals, that is, shapes of the orbitals. What are the different shapes of the orbitals? Last class we studied.
Your voice is not that clear, ma'am.
So last class we have discussed all this. Remember?
Yes, ma'am.
Yes. What are the different shapes of orbitals?
Spherical, double dumbbell, tetrahedral.
What is it called? S orbital, p orbital, d orbital,
D orbital, F orbital.
S orbital.
Yes, we have studied how many electrons it can occupy, and we are interested only S and p orbitals more precisely.
Ma'am, your voice is not clear, ma'am.
Now, electron configuration. Next is electron configuration. So, what is electron configuration?
It is the distribution of electrons, ma'am.
So, there are a number of rules that determine the way in which the electron of an atom may be distributed. So, one of the important among that is Pauli exclusion principle. So, what that principle says is only 2 electrons can occupy any atomic orbit. So, and this atomic orbital which occupies the electron should have opposite spins. They should not have the same spin. These electrons of opposite spins are said to be paired electrons of like spin tend to get as far from each other as possible. And this tendency is the most important factor that determines the shapes and properties of the molecule. So you can see this. So we have discussed the s orbitals, p orbitals, right? So how we have to write the electrons? So each orbit can occupy only 2 electrons. So you can see in the first picture, first one, there is correct distribution of electrons. Second is incorrect. So 1s2, how many electrons? 2 electrons. 2s2, 2 electrons. In 2p also 2 electrons, but of the same spin. You can see the same spin. So if they are same spin, they has to be in different orbits. If they are different spin, opposite, then only they can share the electron in the same orbit. They can fit in the same orbit. So in the second, you can see 1s2, 2s2, 2p2. So 2p2, you can't write the only 2 electrons in one shell. So it has to be distributed in the 3 shells. So 1 empty p orbital and 2 p orbitals with an odd electron. They are not paired. In the second one, you can see. So there are 3 different p orbitals at right angles to one another: px, py, pz. So in each, it has to be filled. So first 1s orbital has to be filled with the electrons. Then 2s orbital should be filled, then 2p orbital, then 3s orbital, then 3p, then you have to go for 4s. So like that only it should be moving electrons. So what are these points to be remembered here? only 2 electrons can occupy any atomic orbital. And if this has to happen means the 2 electrons must have opposite spins. So if they are having same spin means they are going to repel each other. They are not going to stay together. So the most important of all the factors will help in determining the shapes and properties of the molecule. So you can see the electronic configuration. So these are comes under which periodic table, which table it comes under, which row? These are the first 10 elements present in the periodic table. What is the first element present? Hydrogen.
Hydrogen.
Its atomic number is
1.
1. Its electronic configuration is
1s1.
1s1 because it has only one electron. So the first orbital, that is s orbital, is occupied by only one electron. Second element is
Helium.
helium. Atomic number is 2.
2.
Electronic configuration
1s2.
2 because 2 electrons it can occupy the first s orbital. So both electrons can be occupied in one orbital. Third, lithium.
Lithium.
Atomic number 3. Electronic configuration. Now you have 3 electrons. So first orbit is S1s orbit. So 1s orbital will be occupied by 2 electrons and 2s orbital will have the 1 odd electron. Similarly, you can see next element. So as we move on, you can check the electronic configuration. So how the electrons are occupied in the orbital. So we'll move on to sodium. We'll see what is the atomic number of sodium. 11.
11.
So 11. How will you put this electrons? 11 electrons in the electronic configuration. So first orbit 1s2. So 2 electrons. 2s2. 2 electrons. 2p 6. P orbitals can occupy 6 electrons. Then 2s and 2p are second orbital. Together it is 8 electrons. Next remaining is 1 electron that is occupied in the third s orbital. 3s1. So it will be filled in the order only. So unless the first orbital is filled, the next orbital cannot be occupied. So we see that an orbital becomes occupied only if the orbitals of lower energy are filled. Example, 2s actually it became 2 years. 2 years after 1s, 2p, after 2 years. So in the order only it has to be occupied. So we say that an orbital is not occupied by a pair of electrons until other orbitals of equal energy are each occupied by one electron. The example I already shown in this. So if the electrons are not completely filled, it will be occupied. The electrons are occupied in each orbital. So the 1s electrons make up the first shell of 2 and the 2s and 2p electrons make up the second shell of 8. So like that it will be moving on. Then it will be 3s, then 3p and so on. Next is molecular orbitals. So what do you mean by molecular orbitals? So a molecular orbital is a mathematical function describing the location of wave-like behavior of an electron in a molecule. So this function can be used to calculate chemical and physical properties such as finding the electron in an specific region. So you can see the two different orbitals, atomic orbital and molecular orbital. So what you can see the difference here? You concentrate on bonding, leave the anti-bonding, see only the bonding thing. So atomic orbitals, NPZ, you have an odd electron present in the PZ orbital. So when they form a bond, so what happens? There is formation of new orbit, molecular orbital, where there is formation of sigma bond. That is covalent bond. So this is the structure of molecular orbital. So that is formation of new bonds, that is new orbit. Two atomic orbitals club to form one molecular orbital. So a positively charged nucleus is surrounded by electrons are arranged in concentric shells or energy levels. There is a maximum number of electrons that can be accommodated in each shell too. Yes or no? Each shell can occupy its maximum number of electrons. In the first shell 8, in the second shell, in the first shell 2, in the second shell 8 or 18, in the third shell it increases and so on. The greatest stability is reached when the outer shell is full, as in the noble gas. So when the molecules will be stable when the outer shell is full and it is reaching the configuration of noble gas. So both ionic and covalent bonds arise from the tendency of atoms to attain this stable configuration of electrons. So how these bonds are formed? Due to this reason only, because the atoms tend to fill their outermost shell to the octet configuration. That's why you can see formation of or breaking of ionic and covalent bonds. Next is the ionic bond. So ionic bonds result from transfer of electrons. So example you can see here, lithium fluoride. So lithium atom has 2 electrons in its inner shell and 1 electron in its outer or valence shell. So the loss of 1 electron would leave lithium with the full outer shell of 2 electrons. So lithium can lose 1 electron for forming a bond with fluorine. A fluorine atom has 2 electrons. Sorry, it should be fluorine, not fluorine. A fluorine atom has 2 electrons in its inner shell and 7 electrons in its valence shell. The gain of 1 electron would give fluorine a full outer shell of 8. So fluorine tends to become octet. So it wants 1 electron to become octet, to become stable. So whatever the electron lacking in fluorine is taken from the lithium ion. So lithium is giving electron. So when it is giving electron, it becomes what? Electro positive or electron negative?
Electropositive.
Positive, because electron is negatively charged. It is removing from the lithium. So it becomes positively charged. Chlorine is gaining the electron, hence it becomes negatively charged. So lithium fluoride or lithium fluoride is formed by the transfer of 1 electron from lithium to fluorine. You can take either fluorine or chlorine. Both have similar configurations. It has 7 electrons in the outermost shell. Lithium, now there is a positive charge and fluorine has a negative charge, fluorine or fluorine. So the electrostatic attraction between the oppositely charged ions is called an ionic bond. So such ionic bonds are typical of the salt formed by combination of the metallic elements, that is electropositive elements on the far left side of the periodic table with non-metallic elements, electronegative elements on the far right side of the periodic table. ionic bonds. Metallic elements and non-metallic elements formed by the ionic bond. Next is the covalent bond. So this covalent bond results from sharing of electrons. Example, formation of hydrogen molecule. So how the hydrogen molecule is formed? Each hydrogen atom has a single electron. We know that hydrogen atomic number is 1. How many electrons it has? Only 1 electron. So this electron, one electron, is shared by each hydrogen atom to form a hydrogen molecule. So both hydrogens can complete their shells of 2. So you can see here 2 hydrogen atoms with 1 electron each when they are forming a covalent bond. So hydrogens can complete their shells of 2 and they become stable molecules. So you can write H2 or H bond H. The solid line indicates here the covalent bond. Next is polarity of bonds. So covalent bonds have properties, that is polarity. So what do you mean by polarity?
Movement of electron from high electronegative element to low electronegative element.
Yes, polarity is regarding the charge, positive and negative. So two atoms are joined by covalent bond which share the electron. Their nuclei is held by same electron club. So in most of the cases, two nuclei do not share equal electrons equally. That is, electron is denser at one atom than the other atom. So what happens therefore? One atom will be negative and the other end of the atom will be positive. That is, there is negative force and positive force. That is said to be polar bond. When you have this positive pole and a negative pole, then this is called as polar bond. So you can see here example. So polarity can be indicated by using the symbol. What is the symbol used for polarity? Partial positive or partial negative. So partially positive and partially negative charge, that is delta plus or delta minus. Among all these elements, fluorine has highest electronegativity compared to hydrogen, oxygen, chlorine, nitrogen, bromine and carbon. So fluorine will have a partial negative charge and the other atom, when it is bonded with the other atom, it automatically gets the partial positive charge. So polarity of bonds leads to polarity of molecules and affects the melting point, boiling point, solubility. So extra polarity of bond determines the rate of reaction also, which takes place at that point and affects the reactivity of other bonds. So polarity of bonds plays a very important role in reactions also while carrying out the synthesis or preparation. So polarity of molecules. The molecules is polar if the center of negative charge does not coincide with the center of the positive charge. Such molecules is dipole. So dipole is equal and opposite charge separated in space is nothing but dipole moment. So dipole is symbolized by an arrow with a line. So this symbol indicates the point from positive to negative charge. So that means the electron is moving towards the highly electronegative atom. You can see the arrow mark towards the highly electronegative chlorine atom. So this is the symbol of dipole. So can you see here? Dipole, bond dipole. So carbon, the first example, the carbon so you can see here bond dipole, how it is, and molecular dipole. The carbon is less electronegative, whereas oxygen is more electronegative. So the arrow mark is towards the oxygen atom, away from the carbon. Similarly in water, H2O. So it is towards the oxygen from hydrogen atom. So you can see here various examples, the molecules which possess dipole moments. So hydrochloric acid, HCl. And what is BCl3? Boron. What is BCl3?
Trichloride. Boron trichloride.
Yes. What is CH2O? What is CH2O? You can see the formula HC double bond OH. It is formaldehyde.
Formaldehyde.
Yes, it's formaldehyde. Next, ammonia, NH3. Next, what is CHCl3?
Chloroform.
Yes, very good. Chloroform.
Chloroform.
CCl4?
Wait, this one.
You can also say
Carbon
chloroform.
tetrachloride.
Carbon tetrachloride.
Carbon tetrachloride. Next,
Phosphorus pentafluoride.
Pentafluoride.
phosphorus
Phosphorus
pentafluoride.
pentafluoride. Next is sulfurous hexafluoride.
Sulfurous
Hexafluoride.
sulfur hexafluoride.
Fluoride.
So you can see the dipole moment. So HCl, it is more electronegative atom in HCl. Chlorine. Chlorine is highly electronegative atom. So you can see the arrow mark towards the highly electronegative chlorine atom. Similarly, in boron trichloride, chlorine is highly electronegative. In formaldehyde, compared to carbon and hydrogen, carbon is electronegative. So there is dipole moment in towards the carbon. Compared to carbon and oxygen, oxygen is highly electronegative. So there is dipole moment of towards the oxygen. Similarly, ammonia, nitrogen is highly electronegative. In chloroform, chlorine, CCl4, chlorine, phosphorus pentafluoride, chlorine, and sulfur hexafluoride, chlorine. So you can see all the indication dipole moment. So dipole, when two equal but opposite charges are separated by a distance, we say that a dipole is formed. So what is dipole moment then? Dipole moment is indicated by mu. That is dipole moment produced by two equal but opposite charges separated by a distance r. That is given by a formula mu is equal to qr. So what is mu? Mu is dipole moment. What is q? What is q? Here,
Charge. Charge
charge
on
of the
element.
atoms are in. What is that?
I didn't listen. Please repeat once.
Distance.
Yes, distance. Dipole moment mu is the dipole moment produced by two equal but opposite charges separated by a distance r. Mu is equals to qr, and it is measured in dBys. It is measured in terms of dBys. So the magnitude of the charge multiplied by the distance between the two atoms. That is nothing but dipole moment. So molecules like hydrogen, oxygen, nitrogen has zero dipole moment because non-polar. They are also called as non-polar because two identical atoms have same electronegativity and share electron equally. So these molecules H2, O2, N2, they don't have the dipole moment. But in case of hydrogen fluoride, it has large dipole moment of 1.75 degree because of the high electronegative fluorine, which pulls the electron strongly and shows high dipole moment. Next, physical properties of a compound, whether organic or inorganic, depends upon which type of bond holds the atoms together in a molecule. So covalent bonds, this type of bonds are formed by sharing of electrons from each atom. Generally, it is observed in organic compounds. Example, ethane, ethane, ammonia, etc. So ionic bonds, these bonds are formed by transfer of electrons from one atom to another atom. This is generally observed in inorganic compounds and salts. Example, sodium chloride, potassium bromide, etc. So till here you have understood? Any doubts? We have discussed now what is covalent bond, what is ionic bond, what do you mean by polarity of bonds. Yes? Say yes or no.
Yes, ma'am.
So no doubt.
Yes, ma'am.
Yes.
No, ma'am.
So now we can move to properties.
Yes, ma'am.
Okay. So
Yes, ma'am.
what are the important properties we are going to discuss? Melting point, boiling point, solubility. So what do you mean by melting point?
The temperature at which solid becomes liquid.
The melting point is defined as change from highly ordered arranged particles in a crystalline lattice to the more random arrangement in characterized liquid. So where the solid changes to liquid, the temperature at which the solid turns into liquid is nothing but melting point. So when the melting occurs when temperature is reached. That means the thermal energy of particle is more enough to overcome the intercrystalline force that holds them in the position. So before we move on to that, so how the molecules are arranged in solid, liquid and gas, we need to know. So how the molecules are arranged in solid?
Tightly packed.
Very tightly packed. So there is no free space at all. So one molecule is next to the another molecule and they are tightly bound. What about in liquids?
They will have a bit free spaces
Free
in
space,
between.
little space they have. They are not like solid. There is no space only. But here liquids, they'll have the little space. So gas,
Loosely packed.
very, very loosely packed. Here one, there one. So there will be very freely moving molecules. So hence solid can be converted into liquid, liquid to gas. So general basic thing which are learned in the school. So example is water. Yes, ice which is in solid state gets converted into liquid state, that is water, and water again gets converted into vapor, water vapor. It's a gaseous form, and this can be, this is a reversible thing. So gaseous thing can be converted into again liquid by condensation. So again gaseous to liquid, and liquid again when you keep it for freezing, it will form a solid. So these three can be interconvertible or interchangeable. So this, what are the physical properties we are seeing? Have the impact of bonds. Based on what type of bond it is going to change, whether it is an ionic bond or covalent bond.